So this is part 2 of section 3-4. We learned how to solve exponential equations, and this basically uses the idea that we talked about the other day, is that if log base b of x is equal to log base b of y, that must mean that what?
X equals Y.
That must mean that x is equal to y, okay? So that's what we'll use in the second part of this. We won't, so if they say solve, okay, solve for x, we already kind of did stuff like this. 2 log of x equals 5, okay? Solve for x, whoops, solve for x. What do I do first? We did divide both sides by 2, divide by 2. So you get log of x is equal to 5 over 2. How did I make the log go away?
Isn't it log base 10?
Yeah, it's log base 10, but
Just
yeah, it is.
clarifying.
So if there's nothing there, it's log base 10. How do I make the log go away?
You move the 10 over.
You move the 10 over. Where's the 10?
Right? You write the log.
There's a 10 down here if you don't see it, right? So 10 raised to the 5 over 2, you rewrite it in exponential form, is equal to x, okay? Or you can exponentiate both sides. You could put it 10 down, 10 to the log base 10 of x is equal to log of 5 over 2, okay? Whoops, did I do something wrong? I did something wrong. X equals, no I didn't, okay? So log base 10 of x means that 10 to the 5 over 2, right, equals x. And then I just plug that into my calculator, and I get x is about equal to whatever it is equal to. 316.228, okay? It's best to take most of these answers to 3 decimal places, okay? That's just kind of, get used to that. That's kind of what they do on AP tests and stuff like that. So 3 digits is good. Easy enough? We're not quite done, okay? This one's pretty easy too. What if I were to do, okay, example 2. What if I were to do natural log of square root of x plus 2 is equal to natural log of x? You can tell me how to do that. Go ahead, Garrett.
Well, the natural logs just cancel out, so you're left with root x.
Right, because since natural log of this is equal to natural log of that, you just can take away the natural logs and you can say x plus 2, square root of x plus 2 equals x. But you have to be really careful on this with the domain, because natural log, those numbers in there have to be greater than 0. So how do I solve this algebraically? What do I do to both sides? Square both sides, make that go away, make that go away. I get x plus 2 equals x squared, and then I have to get everything on one side. So I get x squared minus x minus 2 equals 0, and that factors to x minus 2, x plus 1. X minus 2, x plus 1 equals 0, and then you draw a squiggly line, you see either x is 2 or x is equal to -1. Which one of those do I need to throw away?
-1.
You have to throw away -1 because you can't, this number has to be bigger than 0, okay? So -1, it's okay over here, but it's not okay over here, so you have to throw that one. 2 works, right? You can take the natural log of square root of 4, which is, you can take the natural log of 2, and here you can take the natural log of 2, right? So it works. But you have to be careful with your domain in those ones, okay? The next one, only 2 more examples, Dan, and then I'm going to be done. Yay, yeah. This is piece of cake today. It's like Christmas. Oops. Okay. So next one, I like this problem. It's fun. Log of x log of x minus log of x minus 3 is equal to 1. So these are kind of tricky, and people say, I don't know it. And I would say, do this without your calculator. Anyone have any ideas? I bet Emily doesn't. You know what to do?
Could you add log of x minus 3?
Well, you could add it to the other side. It's not going to do you much good. Anything else? How can I rewrite log of x minus Jack?
You go log of x over x minus 3.
Good, okay? So if you see something like this with a plus sign or minus, think about rewriting it, right? You could rewrite this, remember the rule, I could rewrite this as log of x over x minus 3, the whole thing, right? Equals 1. Then what? Then what, Harrison?
Like have 10 raised.
Right, so then you can exponentiate, or you can say, oh, I know there's a 10 down here, right? So 10 to the 1 equals this. So 10 to the 1 equals x over x minus 3. Then you cross multiply, and you get 10 times x minus 3, right? Equals x, distribute 10x minus 30 equals x. Did I do that right? I did that right. Subtract x at 30, 9x equals 30, x equals 30 over 9. Right? 30 over 9. And then make sure you plug it back in. Is 30 over 9 okay for in there? Is 30 over 9 okay here? Yes, because that's got to be a number bigger than 3, right? Because 30 over 9 is bigger than 3. So if this were 3, you can't even take the log of 0, right? Because there's no number that I could raise 10 to give you a number that's equal to 0, right? So 30 over 9 works, so you're good. Huh? Last one already, Sarah. Questions? Okay then. So next one says solve for x. Solve for x. Solve for x, and they'll give you natural log of x minus 3 equals negative x squared plus 4. Okay? If you see something like this, and usually they'll say use your graphing utility, which means use your graphing calculator or something like that. If you see something like this, if you try to rewrite it in exponential form, it's not going to do you any good, right? If you know that there's an e down here, you could say e to the negative x squared plus 4 equals x minus 3. There's really no way to solve this algebraically, okay? So that I know of, anyway, because you'd have to somehow. So the only way really to do this is with a graphing utility, okay? So so what you want to do is graph natural log of x minus 3, which for those of you who don't know, who didn't know on the quiz, okay, natural log of x minus 3 is shifted to the right 3 units, okay, shifted to the right 3 units. So that looks kind of like this over here, where you have an asymptote at x equals 3, right? And it goes through the point 4, comma 0, okay? Because it usually goes through 1, comma 0. Got that one wrong, right? And then what does y equal negative x squared plus 4 look like? What does that look like? Come on, tell me you know what that looks like. It's a downwards facing parabola, okay, with a y-intercept of 4. And so this one is going down, and it looks something like this, okay? And this one's going down here. And what you're looking for is this point right here, because that's when those two things are equal to each other, okay? So this is what, so you graph this equation, right? You graph this equation, and you see where they cross. Okay? So let's just do it with your graphing calculator just to refresh your memory. Okay? And for our viewers out there in the viewing audience, of which there are millions, okay? Someone said that their favorite TV show in the last class was Mr. Leader's math videos. So I think they were lying. Okay. So if you did this, you would go to your y equals. You would graph y equals ln of x minus 3. But it's good to have an idea, know what you're looking for before you graph it, so you don't come up to me during a test and say, my calculator's broken, I don't know what's wrong with it, okay? It's because you don't know what your window or should be or something, okay? X squared plus 4. And I would do like, this is a pretty standard window, so I would go zoom 6, which is a standard window. And there's my log function, there's my parabola function. Uh-oh, they don't appear to cross, but they do, guys. I think it continues down this way, it doesn't just stop, okay? So let's see what happens. Second calc, intersect 5, okay? And it'll say first curve, and if it's on this curve, you hit that one. So that's on the log function, and it'll say second curve, first curve. First curve, where was I? First curve, there's my first curve, okay? Second curve, you have to get somewhere close to like, there it is. Second curve, let's just guess. There's only one, didn't I hit it already? Second curve. There we go. So I got it onto the second curve. Then I'm going to hit enter. And then I'll say guess. And my guess is at x is 3.006487. So like this is, you have to move over onto the x values where it actually, okay, go over to like x is bigger than 3, and then I'll go on to that next one, okay? And then it gets, there you go. Got it? Okay, so yeah, because this goes down real steeply, what's happening there, why you don't see the rest of that log function, because at that point it goes down very, very steeply, and there's not enough pixels to actually draw the rest of the curve there. But there is a curve going down with an asymptote of 3. And since they intersect just after 3, it's really, the curve is really, really vertical at that point, you know. So that's why it's hard to find. But you would get approximately x is about 3.008. Okay? And guess what? Thank goodness. I am done.